Now let's talk a little bit about event and interruption processing. What actually happens when the user taps something? The tap is an event that must be processed. The functionality provided in the UI kit framework manages most of the application's infrastructure. Part of the initialization process mentioned before involves setting up the main run event loop and event handling code, which is the responsibility of the UI application object. And here's how such events drive a process inside the app. One is that first you have an event. The user taps a button, for example. The touch of a finger, or actually the lifting of the finger from the screen, adds a touch event to the app's event queue, where it's encapsulated into a UI event object. A UI touch object exists for each finger touching the screen, so you can track individual touches. As the user manipulates the screen with his or her fingers, the system reports the changes for each finger in the corresponding UI touch object. We will go into the UI event and UI touch objects later when we talk about handling touch events. The main run loop monitor dispatches the event. That means that when there's something to process, the event handling code of the UI application object processes touch events by dispatching them to the appropriate responder object. The responder object is the one that has signed up to take responsibility for doing something when that event happens, such as when the user touches the screen. Responder objects can include instances of UI application, UI window, UI view, and its subclasses, all of which inherit from UI responder. A responder object decides how to handle the event. For example, a touch event occurring within a button in a view is delivered to the button object. The button object handles the event by sending an action message to another object, in this case, the UI view controller object. Setting it up this way enables you to use standard button objects without having to muck around in their innards. Just tell the button what method you want to have invoked in your view controller, and you're basically set. Processing the message can result in changes to a view, a new view altogether, or some kind of change in the user interface. When this happens, the view and graphics infrastructure takes over and processes the required drawing events. Finally, you're sent back to the event loop. After an event is handled or discarded, control passes right back to the main run loop. The run loop then processes the next event, or puts the thread to sleep if there's nothing more to do. If we look in the main view.xib file in our sample app, we see that there is a button object. Its name is UI button. It's an instance of the UI button class that does exactly what I said. It intercepts touch events and sends an action message to a target object, the object that's supposed to handle the event. The target object is the responder object I was just describing that decides how to handle the event. In this case, the button is connected to a show info method. Let's show that in the connections inspector. Here, the touch up inside event is connected to the show info method in the file's owner. The file's owner shows the received action show info from the button. And so you can see how you can use standard button objects. And in fact, the template already provides the first one. As I said earlier, in iOS 4.2 and newer versions, various events besides termination can interrupt your app to allow the user to respond. For example, calendar alerts or the user pressing the sleep-wake button. Such interruptions may only be temporary, and if the user chooses to ignore an interruption, your app continues running as before. But if the user decides to tap the alert to deal with it, your app first moves into the inactive state. To see where you would put code to handle the move to the inactive state, take a look at myworldappdelegate.m. Specifically, the application did enter background. This tells the delegate that the application is now in the background. So when the user quits an app, its process is not terminated, but moved to the background where it is suspended to conserve power. If an app needs to continue running, it can request execution time from the system, but we're not going to go into that yet. Because the app is in the background, running or suspended, and still in memory, relaunching is nearly instantaneous. An app's objects, including its windows and views, remain in memory, so they don't need to be recreated when the app relaunches. If memory becomes constrained, iOS may purge background apps to make room for more. But because these interruptions cause a temporary loss of control by your app, meaning that touch events are no longer sent to the app, it's up to you to prevent what's known as a negative user experience. For example, if your app is a game, you should pause the game. In general, your app should store information about its current state when it moves to the inactive state, and be able to restore itself to the current state upon a subsequent relaunch. In all cases, the sequence of events starts the same way, with the application will resign active message, which is sent to your application delegate. It tells the delegate that the application is about to become inactive, and you use the application will resign active method here to pause ongoing tasks, disable any timers, and generally put things on hold. What happens after this depends on the nature of the interruption or how the user responds to the interruption. Your app may be reactivated or moved to the background. If your app is reactivated, for example, a user ignores the FaceTime call or calendar notification or a similar type of interruption, the system sends your application delegate the application did become active message and resumes the delivery of touch events. You have a method in this template called application did become active. This is where you restart tasks that were paused or not yet started while the application was inactive. If the user pressed the sleep-wake button, the system then puts the device to sleep. When the user wakes the device later, the system sends your application delegate the application did become active message, and this method is able to handle it. And your application is also able to receive events again. Remember that while the device is asleep, foreground and background applications do continue to run, but should do as little work as possible to preserve battery life. When your app is reactivated, either because the user ignored the FaceTime call or calendar notification, or because the user pressed the sleep-wake button and the system comes back to life, you can use the application did become active method to restore the app to the state it was in before the interruption. What you do depends on the application. In some apps, it makes sense to resume normal processing. In others, if you've paused a game, for example, you could leave the game paused until the user decides to resume play. The second kind of interruption is when the app is moved to the background. When the user accepts the notification or interruption, or presses the home button, or even if the system launches another application, your app is moved into the background state, where it is suspended to conserve power. When your app enters the background state, it will be sent the application did enter background message, and here is the application did enter background method. In this method, you can save any unsaved data, or what we call the state, which is where the user is in the app, the current view, the options selected, and stuff like that. You can save it to a temporary cache or to a preferences database on the iPhone. Although we don't do this in the My World sample app, your app's delegate can implement the delegate method application will terminate, which is here, to save the current state and unsaved data. So you'd really want to do it in both places. One of the reasons you might use application will terminate to save some data is because if your app is purged, it receives no notice that it is removed from memory. You need to save any data beforehand. The state information that you save should be as minimal as possible, but you still need to accurately be able to restore your app to an appropriate point. You don't have to display the exact same screen used previously. For example, if the user is editing a contact in the Contacts app and then leaves the Contacts app, upon returning to the Contacts app, the app displays the top-level list of contacts. It does not display the editing screen for the contact. That's because an editing function is a rather dangerous situation. You don't want to suddenly jump back into it so that any tap actually edits something. Keep in mind that if your app needs more execution time or has declared that it does some background execution, it's allowed to do that. It's allowed to continue running after the application did enter background message up here. And in this method is where you would implement any additional execution. What happens is your delegate is sent that message, the application did enter background message, and the app has approximately 5 seconds to finish things up. If the method doesn't return before time runs out, or if your app doesn't request more execution time from iOS, your app is terminated and purged from memory. At some point, it's likely that the user will once again want to use your app, which has been patiently sitting in the background waiting for this opportunity to respond to the user's tap. When the user returns to your app by tapping it on the home screen or by switching the pane below the dock, your app delegate is sent the application will enter foreground message and the application did become active message. Here's the application will enter foreground method. Why this is useful is you have to remember that while an app is suspended, the world still moves on, and the iOS tracks all the things the user is doing that may have impacted your application, such as the user may have changed the iPhone orientation from landscape to portrait, and then to landscape, and then finally back to portrait. Although iOS keeps track of all those events, it will send you only a single event that reflects the final change you'll need to process. So if the change is to portrait orientation, in this method, you would handle that. Finally, the application did become active message, which is handled by this method. And I've already explained that this is where you would restart any tasks that were paused to bring back the state of your app.